So today we'll be learning lowest common multiples. So popularly known as LCM. So what is LCM? To simplify it, so I'll be using two methods, and the methods, let's call them method 1 and method 2. So across two examples, so let's find the LCM of these two examples. So first one, that's we'll find the LCM of 6 and 8. Find the LCM of 6 and 8, and B, we find the LCM of 12 and 18. So let's find the LCM of this. So the way LCM is done with big small numbers, that's the same way it is done with big numbers. But what does LCM mean? LCM means the common multiples. That is those multiples that are the same. So let me give you a good example of a multiple. Multiple is like making a uniform ladder. So ladder like that goes up uniformly like this. So we may have it like 2, multiple of 2, 4, 6, 8, 10, 10, and it continues like that. In the same manner, we may have multiples of 4 like 4, 8, 13, 4, 8, 12, 16, 20, and it continues like that. So that's what multiples mean. So multiple is like making a uniform ladder, like when you multiply figures together, what's the common multiple? For instance, now, if we're looking for the common multiple for 2 and 4, so I think the only common multiple they have together is the lowest of it is 4 itself. So let's leave that. So that's exactly what multiple. So multiple is like making a ladder, a uniform ladder. So working with the same figure is very easy. So now let's start with the method 1, the first method, which I will call method 1. So this method 1 is a prime factor method. So we rule our line like this. We rule our line. So like this, we start to divide with the common multiples. So first, we start to divide with common prime numbers that can divide them. So the lowest prime number that can divide is 2. So 2 goes in 6. 2 goes in 6 3 times, in 8 4, 2 goes again, so you continue to use the lowest common multiple until it continues to go. So 2 and 2 3 1 3 1 1. So meaning that the LCM will be equal to the multiples of the figures we have here. That's 2 times 2 times 2 times 3. So that becomes is 24. So meaning that the LCM of 6 and the LCM of 6 and 8 is equal to 24. So let's use the method 1 for the B. So this is A and we have our B. So we rule and we divide with prime numbers. So I'm going to list all the prime numbers, at least the first 10 prime numbers that are common for finding LCM. So we have 12 and 18. So we divide with 2 first because all of them satisfy the test of 2. We have 6, 9, 2 again, 3, 9 doesn't go. So 2, 3, 1, 3, and 3, 1, 1. So you will notice something at this stage, that 2 does not divide this 9, and I just bring the 9 down. So that is the logic. So if it does not divide it squarely, that means if the figure you are using is not a perfect factor of it, then you just bring it down. You don't need to divide and record the remainder. You get it now? So that's how to do it. It's very easy. So meaning that the LCM is equal to the product of this, 2 times 2 times 3 times 3, and that gives us 4, 9, That's 36. So the LCM is 36. So that's using method 1. So the second method is very easy to apply, but it is not suitable for handling bigger figures. It is not suitable for handling bigger figures. So let's use the method 2 here. So our method 2, using the method 2, the LCM. So to do that, you just make a ladder, a uniform ladder. So you have your figures 6 and 8, and you continue to make the multiples of them. So now let's start. 6 times 2, so 6 times 1, 6 times 2, 12 times 3, 18 times 4, 24 times 5, 30 times 6, 36, and you may stop there. So you now make the bigger number to catch up. So 8 times 1, 8, 8 times 2, 16, 8 times 3, 24. So now you can see that we are having a common multiple now, 24, 24. So immediately you have a common multiple, you can stop, and that is the common multiple. So that means the LCM is equal to 24. So I'm using the same method for our B. Let's do it on our B. So we have 12 and 18. So you make the multiple, like I said. So the limitation of this method 2 is that it's not suitable to handle big figures, because to make the multiple will be like wow. So 12 times 1, that's 12, times 2, 24, times 3, 36, times 4, 48, times 5, 16. Then let's make 18 catch up. 18 times 1, that's 18, times 2, 36. So you can see that 36 by 36 and 36, so it has catch up. So we have our LCM to be equal to 36. So this is how to use this method 2 of LCM. So the method 1 is the prime factor method, while the method 2 is just making the multiple like a ladder method, and you try to catch up. So the logic is that you first make the multiples of the smaller figure, then you make the bigger figure to catch up. So immediately you have something that is the same, then you stop. So those are the two popular methods for LCM, and they are quite easy. But method 1 is the best. So how do we apply method 1? So just use the common prime numbers. So now let's have some examples of prime numbers. So examples of prime numbers. So prime numbers, by what they are numbers that can only be divided by 1 and itself. So the first prime number is 2. After 2, do you know what we have? We have 4. Sorry, I was wrong. So after 2, the next prime number is 3. That's a number that can only be divided by itself, because 1 is a universal factor. 1 can divide all the figures in the world. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, so 31. So these are the prime numbers. Then it continues like that forever. So those are prime numbers. So you can start to practice and try to do more examples. So LCM means lowest common multiple. What's the application? We apply this in many topics in the future. So you may see more videos in which we'll be applying this LCM. We also apply it in simplification of fractions. We apply it in algebra as well. So LCM is a very vital skill that everybody is expected to know. So thank you for watching. Please don't forget to subscribe and follow this channel. Thank you.